Yes, welcome to another tutorial of mine. So here from now on we'll be discussing more about trigonometry. As angle is very basic part of a trigonometry, we'll be discussing about angle first. Okay, so like angle and its measurements. So in measurement of angles we'll be discussing about what is an angle and positive angle, negative angle, measure of an angle, right angle, then a quadrant, then measurement of angle, how we measure it, and then degree measure, then radian measure, and the relation between degrees and radians. And these fourth and fifth, sixth topics, which are measurement of an angle, right angle, and quadrant, will be included into 8, 9, 10 topics. Yeah, right. So without any further ado, we'll get into what is an angle, the very basic element, right? So in order to find what is an angle, we'll be doing some small activity which you can see on left side of your screen. So this is basically a circle, right? In this circle the OA is the radius, and as mentioned on your right side, the OA is a fixed ray, and we are coinciding this OA with another OA. For example, let us assume, okay, why? Because they are like coincident very much, right? So then we'll see what we will do is, as mentioned on the right side, now keeping the end O at fixed position and move the other end A. That means keep O as constant. So this center of the circle, we are keeping it very much constant, and we're gonna move the point A. Okay, so when we are moving this point A, when we are moving this point A, it is traveling throughout the perimeter of a circle, isn't it? And it reached its starting point, right? We can notice that, right? So and then, like it went all the way through the perimeter of the circle. Okay, so now what we will do after traveling certain distance, okay, keeping O constant, and will be moving A. After traveling certain distance, we'll point this new point as B. We'll make it as B, and we'll join B with O. That makes a new ray OB, right? That makes a new ray OB. Now the space between OA and OB is called as an angle. The space between OA and OB, the space between OA and OB, this space is called as an angle. So maybe the distance between the respective points might be differing, but all the different distances have same name called an angle. So this is an angle. The space between two lines which are intersecting at a point is called an angle. Okay, so here both the rays OA and OB are originated from O, right? So we call O as vertex. The point O of rotation is called as vertex. Why we are calling O as vertex? Well, because O is the point of origin for OA and OB, right? It is the point of origin for the ray OA and OB. So for both the sides of an angle, OA is the origin, so we call O as vertex. Okay, so next, positive angle and negative angle, right? So in positive angle, if the OB rotates about O from the initial position OA in the anti-clockwise direction, then the angle AOB is called as positive angle. So we look at your left side. So here if you see the OA, for example, this line for now we'll assume as OB. Okay, this stick we are assuming it as OB. If this OB gonna rotate in anti-clockwise direction and making an angle AOB, right? Making an angle AOB. The stick is moving in anti-clockwise direction, and at certain point it gonna make an angle AOB. This angle AOB is called as positive angle. That means, if like in generally we call this OA as initial line. So this initial if a terminal side makes an angle on the anti-clockwise direction of the initial line, then that angle is called as positive angle, right? If any terminal side makes an angle on the anti-clockwise direction with the initial line, then it is called, or with the initial side, it is called as positive angle, and vice versa is negative angle. We'll see that now. So if same OB rotates about O from the initial position OA in the clockwise direction, see, in the clockwise direction, then the angle AOB dash, can you see that? AOB dash, AOB dash is called as negative angle. So now AOB dash is called as negative angle because the terminal side is making an angle on the clockwise direction of OA, right, of initial line. The terminal side is making an angle on the clockwise direction of the initial line, so this angle is called negative angle. So if any angle made on the anti-clockwise direction of the initial line, it is called positive. If the same angle is on the clockwise direction, it is called as negative angle. So here the negative angle will mention minus 30. Okay, and most importantly, this angle, this negative angle, we are gonna calculate this way. Okay, and positive angle goes this way. So from here 30, 45, 90, and then 180, 270, 360. For negative angle it goes this way: 0, 45, 90, 180, 270, 360, right? Very good. So here if any angle goes this way on the clockwise direction, we mention it with minus 30. So don't forget that. So after this, we are gonna discuss about measure of an angle. How we measure an angle? So it is the amount of rotation from initial side to the terminal side. As we said, the amount of rotation from the initial side to the terminal side, this space is called an angle. So how do we measure that? So there are two systems for measuring of an angle. So one is your degree measure, which is also called as hexadecimal system, and the other is radian measure, which we also called as, which is a part of circular system. So we'll discuss about degree measure. So in degree measure, each, like for example, before discussing about degree measure, let me tell you, this is quadrant 1, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So quadrant means it starts from here and here. For example, if you think this as x-axis and this as y-axis, so this x and y axis are dividing this circle into 4 parts. You see that, right? So this part from A to here, it is called as Q1. So this portion is called as Q1. Look at your left side. So from A to O, and from here Q1, and from back to A, this portion is called as completely Q1. And similarly, from O, Q2 until here, this portion is called Q2. This is Q3 and this is Q4. So these axes, this x and y axis are dividing circle into 4 quadrants. Okay, this is Q1, Q2, and Q3 and Q4. So each quadrant makes an angle of 90 degrees at the center. So this is a 90 degrees angle. Okay, each quadrant makes a 90 degrees angle at the vertex, at the center of the circle, right? So if this 90 degrees is divided into 90 equal parts, then each part is called as a degree. Okay, so what is mentioned there is, if this 90 degrees is divided into 90 equal halves, each half is called as a degree. So one right angle is equal to 90 degrees. So this is also called as right angle. Okay, so from Q1 to O to A, this is also called as 90 degrees. So this 90 degrees is equal to one right angle. Okay, and then each degree is divided into 60 equal parts called as a minute. Okay, so this you have to remember. This I can't show you technically, but for example, this is 1 degree, and this 1 degree, for example, if this is 1 degree, for example, this 1 degree is divided into another 60 equal parts, where each part is called as a minute, and this minute is represented with a single inverted comma. beside 60, as you can see on the right side. 1 degree is equal to 60 minutes, and each minute, you know, is equal to 60 seconds, which is like how it is denoted is also I showed you in the PowerPoint. Okay, so this is all about degree measure. Fine. So now we'll go like in degree measure. I will like revise it. So in every quadrant makes a 90 degrees at the vertex. So if you divide these 90 degrees into equal 90 parts, each part is called as a degree, and this degree is equally divided into another 60 parts. Each part is called as a minute, and you know that each minute is divided into 60 equal parts, which is called as second. And that's it. That's about degree measure. Now the most interesting thing is radian measure. So here in radian measure, an angle subtended by an arc at its center is measured by dividing the length of the arc with the radius. That means, so what is an arc basically? The arc is BA. So this curved line is called as an arc. So this arc has two hands, OA and OB. So this OA and OB of the arc are subtending an angle at the vertex. It's like this. For example, if you are the arc and you are putting your two hands this way before you, these both intersect here, right? So this is the angle subtended by U. U means the arc. So with your hands you are subtending an angle at the verge of your hands, right? Similarly, if this arc has two hands, OA and OB, they are subtending an angle at the vertex. Okay. So now sorry for that. So now by dividing the length of this arc with the radius, so OA is a radius, OB is a radius of circle. So length of this OA, so if we divide the length of BA with the length of OA, the radius, then that is called a radian. Okay, so angle is equal to, no, not a radian, the angle is measured in radians. So if you want to measure this angle in radians, just now we measured in degree. So in this case, if you want to measure in radians, then you have to divide this length with radius. You will get this angle in terms of radians, this different unit. Okay, like for length we have meters and kilometers. In angle we have different units, degree and radians. If you want that angle in radians, you are supposed to divide this BA length with OA. Okay, so then in this system the angle is measured in radians, as I already told you. Here the radian is an angle at the center of the circle subtended by an arc of length same as radius of the circle. So what if the length of this arc, this BA arc, this curved line's length is equal to OA? That gives you the value of 1 radian. That gives you the value of 1 radian. I am trying to tell you that if the length of BA is equal to the radius, then by dividing both of them you will get 1. That is 1 radian, right? If say for example this is 10 meters and the radius is 10 meters, then you are gonna, when you divide them, you will get 10 by 10 equal to 1. That means the angle in terms of radian is equal to 1 radian. So 1 radian is equal to the length of the arc whose length is equal to the radius divided by the radius. So that's 1 radian, right? That you can see here. That's it. So then after this, the relation between degree and radians. Fine. So now I hope you understood what is a degree and what is a radian. Okay. So now what is the relation between these two? So for example, so what is 180 degrees? So from here to here is 180, right? How it is? Why? Because this is 90, this is another 90, so 90 plus 90, 180. So the angle from A to O to this end is called 180 degrees. This 180 degrees angle is equal to pi radians. Okay, so if I transfer the pi to the LHS, it becomes 180 degrees by pi, which is equal to 1 radian, and we all know that pi value is 22 by 7. And now 180 degrees into 7 by 22, that is reciprocal of 22 by 7. Why? Because if like 22 by 7 is in the denominator, then if 7 goes into the numerator, it becomes 7 by 22. So 180 degrees into 7 by 22 is equal to 1 radian, which is 57 degrees 16 minutes, which is 57 degrees and 16 minutes. So that's it for this video. So we are done with an angle, how an angle is formed, and what is the right angle, how we measure. So if you have any doubts, you can go back and repeat the video to understand this. So if you have any doubts, you can comment, or you can email me, or you can post them on my Skype ID, or you can post them or you can ask me on my weekends doubt session. Yeah, the doubt session will be like 4 o'clock in the evening of every Sunday. So you can post your doubts, you can ask them all there. So if you like this content, for more such practical, or for such more working models, uh, like and share and subscribe to my channel, and do like my videos. And if you want any improvements to be done, please comment below this video, and I hope you like this video. And that's for it, and tomorrow I'll be going more deep into this trigonometry. So fine, chalo, see you tomorrow with another beautiful content. Bye.